Hello. So in this question, this is a very good question. Because in this question, there is a solid sphere. The charge is uniformly distributed in this solid sphere of radius r1. And the question says if you make a cavity of radius r2 inside this solid sphere. Okay, so if you have that cavity inside the solid sphere, so at any point inside that cavity, so what is the relationship between the electric field and the, let's say, position vector or the radius vectors in each of these options? So how do we answer this question? Okay, so one way to address this problem is take the help of shell theorems, or you can take the help of Gauss law. Okay, but when you take the help of shell theorems or Gauss law, work with vector quantities. Okay, so write everything in terms of vectors. So this is what I propose to do. So take some point inside the cavity. So let's say I have a point here. Okay, so I hope you're able to see that. So let's give some other color, let's say. So that is the point here. So let's call that point maybe, I don't know, Q. Okay, so let's call that point Q. Now from the original center, okay, from the original center, if I draw a line, okay, till that Q, I have some vector here. So let's say this vector, you can say that it is R1. And from the center of the cavity, let's draw another vector. So that is R2. Okay, so let's call that R2. So maybe what I will do is, it's very difficult to see there. So that is the original center O. Okay, so I have the cavity center P. So I have taken a point Q somewhere here. I'm joining point Q with the original center. I'm saying this vector is R1. And then join that Q with the center of the cavity. So I'm saying that vector is R2. Okay. Now, if I consider, okay, so if I consider that, let's say there is no cavity. Okay, so if I consider that there is no cavity, and then I'm trying to get the electric field due to the entire charge present in the bigger sphere at that location Q. So in that case, I have to consider only the charge within radius R1, right? So I have to consider only within radius R1. So that would generate an electric field radially outwards. Okay, so that is E1. And so E1 is considering, okay, so E1 is due to the total charge, due to the charge in the complete sphere. Charge in the, let's say, complete sphere of radius R1. But of course, okay, so when you consider the total charge, while calculating E1, you have to consider only the charge within radius R1. So similarly, if I consider, let's say, the charge within the cavity, okay, so let's say before removing the charge, so if I consider the charge that was present in the cavity, that would create an electric field in this direction. Okay, so that would create an electric field in this direction. So that's is E2. So E2 is due to the charge, that was present in the cavity. Okay, so due to the charge that was present in the cavity. So if the charge were there, okay, so in the cavity. So now you don't have that charge. Okay. Now how do I compute E1? E1 in terms of magnitude will be 1 by 4 pi epsilon naught. Okay, so for me the charge within radius r1 is important. So if I take the charge density as rho, that gets multiplied with volume 4 by 3 pi r1 cube by r1 square. So now if you closely look at this, so what do we have here? So 4 pi disappears. So I can write this as rho by 3 epsilon naught, okay, r1. So vectorially, if I want to write this vectorially, so what is E1 as a vector? It will be rho by 3 epsilon naught r1. Now, using the same logic, if I consider the charge that was present inside the cavity, I'm only looking at that charge. So that would give me this electric field vector E2, which will obviously be rho by 3 epsilon naught r2. Now we don't have that charge. Okay, so since we don't have that charge, the net electric field will naturally be E1 minus E2. Okay, so E1 minus E2, which is rho by 3 epsilon naught into R1 minus R2 vector. Now let's look at this. What is R1 minus R2 vector? So if you think about it, R1 minus R2 vector is this OP vector. Okay, so this is R1 minus R2 vector. I think the options are indicating that this is A vector. Okay, now it's a very important result. So if you look at the electric field, it is rho by 3 epsilon naught, and then it is in the direction of that vector OP. Okay, so that point Q we have just taken inside the cavity. Okay, it could have been any point inside the cavity. So that means what? Doesn't matter what points you take inside the cavity, the electric field is constant both in magnitude as well as direction here. Okay, and it depends only on the A vector, which runs from the center of the original sphere to the center of the cavity. So the electric field is uniform. Okay, definitely uniform. Its magnitude is, can I say it is independent of A? No. Okay, its magnitude and direction depends on A. So the answer should be D.